Okay, we're now in the fourth chapter of the third unit, and we're going to be exploring compound interest. So today we're going to understand the concept of getting interest on your interest. We've learned that with principal or with simple interest, you're just earning interest on that principal balance that you put in there. But with compound interest, you actually earn interest not only on that principal, but on the interest that you're earning as well. We're also going to compute that compound interest using a table. So let's get started. For the first example, it says, how much interest would $1,000 earn in 1 year at a rate of 6% compounded annually? So, if you've gone through all the vocabulary, you understand that compounding annually means that it compounds one time per year. Well, when you're looking at simple interest, you're basing that on a year's period. So, in essence, compound interest, or compounded annually, is actually the same as earning simple interest, because it does not post that interest in the account for you to be earning on the interest until the end of that year period. So we're going to go back to what we were doing before. I equals, P equals, R equals, and T equals. And it says $1,000 1 year at a rate of 6%. So when we plug that in, we've got 1,000 times 0.06. I don't need to put it there, but I will just for sake of being able to see it, times 1 equals $60. So it says how much interest? It would be $60. The second question would, what would the new balance be? So I'm going to take the $1,000 and I'm going to add the $60 to it, and the balance would be $1,060. Please press pause and solve this question. When you're ready, press play and we'll go through it. Okay, so again, we're looking at IPRT, and it says how much would X dollars, so principal is X, earn in 1 year at a rate of 4%. So as a decimal, that's written as 0.044. And it's just interest equals the principal times the rate times the time. So multiplying that out, the interest equals 0.044 times X. And that's your answer. Okay, now for the next example, it says Maria deposits $1,000 into a savings account, and it pays 6% interest, so that looks kind of familiar. It's still $1,000, and it still pays 6% interest, but it's compounded semi-annually. Now remember, semi means half, and annual means year. So it compounds every half of a year, and there are 2 halves to 1 year, so that means that the time is half of a year, because remember, time is always expressed in terms of a year. So if it's compounded semi-annually and we're using the simple interest formula, we need to check it each time it compounds. So plugging that into my formula, I've got I equals 1,000 times 0.06 times 0.5, which is that half of a year. When I multiply all that out, I get $30. Now here's the key of where compound interest works. We're 6 months into this 1 year account. That $30 is going to post to the account, and you now have a new equation because it's asking for the balance after 1 year, not after 6 months. So we're going to add the 1,000 and the $30 that we just earned. So now your new principal balance is $1,030. The rate didn't change, it's still at 0.06, and now we're looking at the second half of the year, so we're looking at 0.5, just like we were in the first equation. When you multiply those through, you find that it's $30.90. Now it doesn't seem like much of a difference, but it is a difference, and we're only talking about $1,000 in a half a year period. So the balance after 1 year, I'll take the 1,030, which was the balance after 6 months. I'm going to add the $30.90, and the balance is $1,060.90. Now remember that 1 year simple interest or compounded after 1 year, the balance was $1,060. So the difference is that 90 cents when it compounds semi-annually. Please press pause, solve this, and come back to me when you're ready. All right, it says here that Alex deposits $4,000 into a savings that pays 5% interest, and it's compounded semi-annually, so that's just like the previous example. So I know that my time is 0.5 because it's half of a year. What is the balance after 1 year? So we're following the same process that we just did in the first example. This is just your turn to practice it. So interest equals 4,000 times 0.05 times 0.5, and I get a total of $100. That's after a 6-month period. It wants the balance after a year. So now we've got a new principal, which is the 4,000 plus the 100. So my new principal is now 4,100 times 0.05 times 0.5. And I end up with 102.50 cents. When I add that in, it's 4,100 plus $102.50. So my balance after 1 year is $4,202.50. All right, the third example, how much interest does $1,000, this should look familiar, earn at a rate of 6%, compounded quarterly? Now when you ask yourself quarterly, how many quarters are in 1 year? Well, there are 4 quarters, just like there are 4 quarters in a dollar, there are 4 in a year. So if $1 is broken down into 4 different sections, I've got 25 cents, 25 cents, 25 cents, and 25 cents. It works the same way with the year. If I'm compounding it quarterly, it means every quarter of a year, I am going to post that interest. So we're going to plug in the same formula. I get 1,000 times 0.06 times 0.25, and with that I get $15. Now here it just says what is the balance after 3 months. And so I'm going to add the 1,000 and the 15. Now I could go through and do this process 4 times because there's 4 quarters in a year, and I would see what it is after a year, but fortunately for us, it only asks for us to do it once. Please press pause, solve this, come back to me when you're ready. All right, this question, it says, how much does $3,000 earn in a 6-month period at an interest rate of 4% compounded quarterly? So the compound is the key that we're looking at, so that was just like the question prior to this one, except the only difference is the other question asked for 3 months, this asked for 6 months. So you should have done this process 2 times to get the correct and final answer. So plugging it in, I get 3,000 times 0.04 times 0.25, which equals $30. I'm going to add that $30 to the 3,000, so 3,000 plus $30 gives me $3,030 as my new principal. my rate stays the same, my time stays the same. When I multiply that through, I get $30.30. I'm going to add that to the $30.30 that I used for the 3-month period interest or principal. And when I add these together, I get a total of $3,060.30 after a 6-month period. All right, how much interest does $1,000 earn at 6% compounded daily? Well, I know that I'm looking at 1 day out of 365 days, so my time looks like that. Plugging it into my formula, I have 1,000 times 0.06 times 1 divided by 365. Now, when you're plugging this into the calculator, it's going to be very important that you include the parentheses around that, or PEMDAS will not follow the process correctly. When I multiply that through, I actually get an answer of 0.16. So in 1 day, I earn 16 cents on that account. Please press pause, solve this, and come back to me. All right, how much does X dollars earn in 1 day interest? So I'm looking at the 1 divided by 365 again at a rate of 5%. 0.05 is a decimal, so it's X times 0.05 times 1 divided by 365. And when I multiply that through, I get 1.3696 times X. If I wanted to round that, I could probably say here 1.37X algebraically. All right, last question. Jennifer has a bank account that compounds interest daily at a rate of 3.2%. The principal is $1234.98. She withdraws $200 for a car repair, receives a $34 check from her health insurance, and deposits it. On the 12th, she deposits $345.77. What is her balance after July 12th? So we're really just going to walk through the process of how this ledger works with a bank. So July 11th, it looks like she deposited a check and took a withdrawal. And when she did that, she ended up with $1,068.98. She earns interest on here, and it says here that she earns interest of 3.2%. So if I take the 1,068.98 and multiply it by 0.032, I end up with 9 cents. If I add that 9 cents down, the end of my balance on the first day, or July 11th, is $1,069.07. And you'll see that the ending balance for that day is also the beginning balance for July 12th. On that second day, she deposits the check for $345.77. When I add these two values together, I end up with $1414.84. I take that $1414.84, multiply it by the same 0.032 that they earned, and what do you guess that they earned? If you guessed the 12 cents, that would be correct. We add these values together, so the balance at the end of day on the 12th was $1,414.96. Good job on this one. Look forward to seeing you on the next lesson.